Okay, hi everyone. Here I'm solving another question that is good if you are an undergrad student who is taking a second year circuit course, or you are applying for your PNG certificate and you need to do some technical exams in electrical engineering. Usually circuit analysis is very easy to take, so this can also be a good example for that, for people who are taking that exam. Okay, so here the question says, write the node voltage equations for V1, V2, V3, and V4 and solve for it. So let's see what we have here. Okay, usually when they say these write the voltage equations, you need to write KCL or KVL basically, where you would choose the nodes and then find how you can relate them. Okay, so let's just start with that. Okay, so again, either you can do that, or let's just start by looking at it. The circuit would tell us. Okay, usually you want to start from the left side of the basically circuit, and you can write within the loops itself, you can write, as I said, KCL or KVL. Okay, since we have a mix of everything here, I would suggest just start with one. Right now I want to write, we can actually let's look at it here. V1, we have a current here. Okay, we have a current that is that would go down. Let's call this I1, and then I1 is exactly equal to V1 over 5 ohm, and that's the direction. Okay, so that's what we found. This is I1. Okay, and then through this node we have another current that is going to go this direction, and these are just assumptions, right? These are just basically some imaginary current directions. Okay, and then we have another current here. Let's call this one IX, and then IX is exactly equal to Vx, because it's the only current going through the 5 ohm is Vx over 5 ohm. Okay, so here we have a couple of equations already, so let's write those. So we have at node 1, I'm going to call this node 1 right here, node 1. Okay, at node 1, what do we have? We have I1 plus I, whatever we call this, we don't know what is this current. Let's call it I prime 1 plus I prime 1 is equal to plus Ix. All of these is going to be 0. Okay, and you're like, doesn't this want the voltage equations? I'm like, okay, wait a second, we're gonna go there. Okay, it's kind of like a hard it's a mix of equations. We have to use the currents and the voltages because we have everything here. Okay, so I1, it's V1 over 5. I prime 1, let's keep it as it is because we don't know how much it is. Here we only have a voltage difference, we don't have anything else, plus Ix, which is Vx over 5, is equal to 0. Okay, then we have another relation here. We know V1 between node 1 and node 2, we know that V1 minus V2 is exactly 15 volt. Okay, that's another useful thing we know. So that's one of our equations right here, because it says find the equations for those. Okay, then what do we have? Then we know that we have 5 amps coming here. So let's write another one at node 2. We have 5 amps current, coming in. So we can call, we know that again, all the currents coming in should be 0, or all the currents going out must be 0. So I'm going to call this I23, and I'll say I1 prime plus 5 amps plus I23. I'm going to add all of these as plus because all of them have the same direction toward the node. Okay, if I chose I23 to be the other way like this, then I had to put here a minus because the direction of I23 compared to the other currents was reversed toward the node. But now all of the currents are coming toward the node, I23, I prime 1 and 5 amp, so I can put all of them relative to each other as positive. Okay, then we have another equation, which is I23 is basically V3 minus V2 over 2 ohm. Okay, so still this is not the perfect one because we still don't know what is I prime 1, but we're gonna get to that. Okay, but now for now we have I prime 1 plus 5 ohm plus V3 minus V2 over 2 ohm is 0. Okay, this is kind of like another equation, but we have to get rid of I prime 1 and replace it with V1 and V2. We have another one here, but I'm going to put these in dash because they're not complete equations of exactly V1, V2, V3, V4. Okay, so we went at node 2. Now we can go at node 3. At node 3. So you see, I'm using the nodes and then also the voltages compared to each other. Okay, and node 3, what do we have? At node 3, we have I23 going out. It's the same one. Then we have this, let's call it I3, going out. And again, we have another current here, which is going to be, let's call it I34. Again, I'm choosing all of the currents in the same direction, so it would be easy. Okay, at V3, at node 3, again, I23 is going out, I3 is going out, I34 is going out, and the summation must be 0. I23, we already know it's V3 minus V2 over 2 ohm. I3 is V3 over 6 ohm. Okay, and then I34, we don't know, it's one of those, again, the hard ones because we don't know yet. Okay, this is another one. At node 4. At node 4, node 4 is coming together, guys, I promise. Node 4, we have IX coming here. Remember, this is the same one. I34 is coming in, and then I'm going to call this I4, which is V4 over 2, and now you would see the difference. Compared to node 4, I'm going to call the ones that are coming toward the node positive. So this is IX plus I3, 4. And then the ones that are going out is going to be minus I4. So this is the first time we are using a minus in this KCL. IX was equal to Vx over 5, Vx over 5, plus I34, which we don't know what it is, minus I4, which is V4 over 2. So this is another one. But then we also, from this relation, we know that V3 minus V4 is 2Vx. So this is another one. We have to get rid of Vx. Okay? Can we do it here? Still not, I'm guessing, right? So that's another one. Right now, we wrote it for that one, for this one, and okay. Now we can, so we have I34 Vx and I prime 1 that we have to get rid of, okay? And then let's see what else we have. What we can do for now is like remove I prime 1 here, like replace it. I prime 1 is minus Vx minus V1 over 5, right? So we replace this one here. So at least we don't have everything. So that's minus Vx minus V1 over 5 plus 5 plus V3 minus V2 over 2 is 0. So that would give us, oh, actually, no, that's a great idea, because here we can replace Vx with V3 minus V4 over 2. Okay, so all we need to do to bring this equation to here, so at least we would get one other good equation that only has V1 till V4. So let's do that. So we have, let's simplify this. Let's multiply it by 10 minus 2 Vx plus V1 plus 50 plus 5 V3 minus V2. So I multiplied this by 10, both sides. And then I'm going to replace the Vx by minus 2 V3 minus V4 over 2 plus V1 plus 50 plus 5 V3 minus V2 is equal to 0. Okay? Yay! So we have V4 minus V3 plus or minus 2V1 plus 5V3 minus 5V2 is minus 50. We can simplify this. V4 plus 4V3 minus 5V2 minus 2V1 is minus 50. That's another equation. So we found the second equation. In order to solve for V1, V2, V3, we need 4 equations because we have 4 unknowns. So that's our second equation. Oops, not good. 2, and this is our 1. Okay, what else do we have? Okay, we have to get rid of this I34 as well. Okay, let's focus on these two. This one and this one. Okay, I think we can do a similar thing. Okay, so we can go from here to this one or the other way. So let's convert star 1. Star 1 is V3 minus V2 over 2 plus V3 over 6 plus I34 0. Okay, I'm just repeating it here. And then let's replace Vx as well in the star 2. Star 2, Vx over 5, that's going to be V3 minus V4 over 10 plus I34. I'm going to get I34 from here. That's that's 6V2 plus minus 8V3 over 12. I tried to do it. Is that right? We have, yeah, 8 of V3, and then we took it the other side too. So now, star 2, we're going to replace I34 to here. So it's going to be 6V2 minus 8V3 over 12 minus V4 over 2. That's our third equation basically. So now we need to go to here, we can do, I don't know, 60 or something like that. Probably, yeah, 60. Multiplied by 6, this is going to be 6v3 minus 6v4. And this is multiplied by 5. It's going to be, so I'm multiplying all of this by 60, guys. 60, so 530 v2 minus 40 v3 minus 30 v4. The other side stays 0, so we have a lot of v4. Minus 30 v4, oh no, minus 36 v4. You can multiply it by minus 2 if you don't forget. So that's like 36 v4, 6 v3 here, minus 34 plus 34 v3 plus 30 v2, which is minus v2, and this is 0. Okay, so this is our third equation, if I didn't make a mistake. Okay, and then what else? Now let's go back to the circuit. So we wrote it at node 1, 2, 3, and 4. And then we used the voltage difference between these two, voltage difference between these two, voltage difference between these two. We have another voltage difference. We can use it here. Look at this, guys. Vx is between node 1 and node 4, right? And their voltages must be the same. So right now, we did all of the nodes together, but we didn't do node 1 and node 4. Between node 1 and node 4. Okay, we are pretty far away, but that's why I'm gonna continue here so you can see the circuit at the same time. So if we write that, because node 1 and node 4, on one side their voltage is basically Vx, right? Vx. On the other side, it's equal to 15 volt. Okay, this is kind of confusing unless we write it as a loop. Okay, I don't want to write it here. I'm gonna go as a loop, like inside here, and then write the voltages. Okay, start from this point. Start from this point. We are going in with the current direction that I drew here. Okay, first one is Vx, and you're entering from the plus as you're going clockwise, so we are putting plus Vx. The second one, as we are entering, this is the way we are going, just follow it, is the second one is minus 2Vx. And then the third one, as we are going through the current direction, it's going to be plus 2I23, okay? Which is going to be V3 minus V2. But okay, let's leave it as 2I23. And then minus 15 volt. This is the trickiest one, because otherwise we wouldn't get the fourth equation. So remember to use all of the circuit. So we have minus Vx plus 2I23, which is basically V3 minus V2, plus V3 minus V2, minus 15 volt is 0, okay? And Vx is basically V3 minus V4 over 2. So again, we are replacing it here. Remember this one? We are putting it here as well. V3 minus V4 over 2 there's a minus here, so this becomes like this. V3 minus V2 minus 15 volt is 0. So we have another equation, which is going to be V3 over 2 plus V4 over 2 minus V2 minus 15 is 0. And this is our fourth equation. Okay, so we got all of our equations. 1, 2, 3, 4. Now we can solve for the voltages, the second part. Okay? Now we have to go by omission, right? So we have one equation that relates V3, V4, V2. We have another one here. And if we can replace V1 here, then by the equation in 1, then we're good. But first, let me rewrite all of our equations. Equation 1 tells us V1 minus V2 is 15 volt. Equation 2, I'm gonna start from V1 so we can see them correctly. For V3 plus V4 is minus 50. Equation 3 is, again, I'm gonna go by 0 minus 30 V2 plus 34 V3 plus 36 V4 is 0. Fourth one, and the last one we found. Let's multiply it by 2. Minus 2V2 plus V3 plus V4 is equal to 30. So I multiplied number 4 by 2. And then I wrote it. So it's simpler. Okay? Now you can go ahead and solve this, but if you want to do the practice with me, let's do it. So we are replacing V1 with V2 plus 15 volt. And we are rewriting this one. Minus 2 V2 minus 30 minus 5 V2 plus 4 V3 plus V4 minus 50. And then if we rewrite this one, again, it's going to be minus 7 V2 plus 4 V3 plus V4 is equal to minus 20, because minus 50 and the 30 goes over there. So that's our equation, V2, V3, V4. Then we have another V2, V3, V4, and then another one, okay? So you can continue by removing V2 in all of these to find V3, for example, okay? So we can, let's do this one. So we can replace, I really like 2V2 here. The numbers are crazy, but we can write V4 as 30 minus V3 minus plus 2V2. And then replace V4 in all of these, in these two, and then that way we get V2 and V3. So then we have minus 7 V2 plus 4 V3 plus V4, which is 30 minus V3 plus 2V2 is minus 20. I rewrote equation 2 with this information here. Okay, and then equation 3 becomes minus 30 V2 plus 34 V3 plus 36 V4, which is 30 minus V3 plus 2V2 is 0. Okay, now the game continues. V2, this one, maybe it hurts your eyes, so let me just minus 5 V2 plus 3 V3 is equal to minus 50. This one, we have minus 30 V2 and then 72 V2 here. So 42 V2, V3. We have 34 here, minus 36 here. So minus 2 V3 is equal to 36 multiplied by 30. That's 0, 8, 1080 minus. Okay, so, and now again, we can do the same thing. And then, but as soon as you get one of them, then it ripples back, right? It's easy. So yeah, you can continue this, but in order to get closure, let's just finish it. So we know that I feel like V3 would be easier, but no. Let's see if this one solves it. It wouldn't help you in the exam, but it would help me now to finish this. And did it detect it correctly? Yes. It can't apparently process it. That's bad. Okay, it leaves it to us. Okay, almost there. So let's do V3 is minus 50 plus 5 V2 over 3. So 42 V2 minus 2 V3, which is going to be minus 2 minus 50 plus 5 V2 over 3 minus 1080. And then we have 42 V2 plus 100 over 3 minus 10 V2 over 3 minus 1080. So 42 minus 3 something is going to be almost. You can probably skip ahead at this point. 10 over 30 minus 42. So that's 38.6 V2 is equal to 103 plus 1080 minus 117.3 over 38.6. Our V2 is going to be minus 61.3. Okay, I might have made a mistake here, guys. I'm just showing you the process. I might have made an arithmetic mistake or something. Now V3 is going to be minus 50 plus 5 minus 61.3 over 3. Let's see if it will solve this one for us. Bad writing. Okay. So 561.3 plus 50 . I have a feeling I did make a mistake somewhere, so these they look a little bit weird. Okay, then we can go back to remember we did V4 here, so we can do V4 is 30 minus V3, so it's 188 plus 2V2 plus 2 multiplied by 61.3 is equal to, yeah, these are too large. I think I made a mistake plus okay, tell me, like, I think I made a mistake somewhere, but you guys catch it, okay? Tell me, where did I make a mistake? I probably did, I'm sure. V1 is V2 plus 15 volt. So that's minus 61.3 plus 15 volt. And that is going to be minus 46.3. Okay, so you see again, part 2 had only a little bit of doing because we mostly did the part in part 1. So if we didn't make a mistake in part 1, part 2 is going to be like we would get most of the grade anyway, because it's solving the equation, which is like ridiculously long. Okay, thank you for watching another video. I hope this was helpful. Again, second year undergrad students who are taking electrical engineering or mechatronic courses can use this as an example to prepare for their finals or midterms. And then also people who are taking their PEng exam and need to basically prepare for their technical exam. Okay, bye.